Hello viewers, on the board is a question on differentiation, and we are asked to prove that arctan x is equal to 1 over x squared plus 1. Now the solution is as follows. Understand that arctan x is the same as tan inverse of x, right? So this arctan x is tan inverse, that is tan raised to the power minus 1x. Now, since this is what we are asked to prove that this is equal to this. So, why not let this equal to an unknown variable? Let's see why. So, let tan inverse of x equals to y. Alright? Now, from indices, tan inverse of x simply means 1 over tan x, alright, from indices, tan raised to the power minus 1 is 1 over tan equals to y. Now this guy can be written as x equals to tan y. That is, this tan travels down, cross multiply. So x equals to tan y. Alright? Now what we are going to do next is to differentiate across. We differentiate x, we also differentiate y. When you differentiate x, what you have is dx. That is 1 dx, right? And 1 dx is also dx. Equals to, when you differentiate tan y is a standard derivative. That is, the derivative of tan y is standard, right? So, the derivative of tan y is sec square y. The derivative of tan y is sec square y. It's a standard derivative, dy. Why dy? Because it's an implicit function, right? When we are differentiating an implicit function, especially y, you add dy after you have differentiated y. So the derivative of tan square y, tan y is sec square y dy. And we can also rewrite this as dx over dy equals to sec square y. That is, divide both sides by dy. Dx over dy equals to sec square y dy. And in differentiation, we are used to dy dx, not dx dy. So if I'm going to change this guy to dy dx, it means I will need to take the reciprocal of dx dy. And one thing about the equation is that whatever you are doing to the left hand side must be done to the right hand side, and vice versa. So if I will take the derivative of dx dy, then I will need to take the derivative of sec square y. I mean the reciprocal rather. If I will take the reciprocal of dx dy, then I will need to take the reciprocal of sec square y. So the reciprocal of this, that is to flip it, of this is dy dx. The reciprocal of this is 1 over sec square y. Now, where do I go from here? Remember, this is not our final destination. This is what we are asked to get. Alright? This is what is expected of us. Now, recall from trigonometric identity that sin square y plus cos square y is equal to 1. But what I need is sec square y, and I don't have it here. Alright? So what I'll simply do is to divide, for me to have sec square y, I'll need to divide throughout by cos square y. Why? Because the reciprocal of cos is sec. Alright? Don't forget this is what we are looking for. So, and I need sec squared from here. So the reciprocal of cos, that is 1 over cos, is sec. So I will say divide both sides, or divide through by cos square y, and cos square y. Sin y over cos y is tan y. It's a standard identity. So therefore, sin square y over cos square y becomes tan square y plus this is 1 equals to this is sec square y. So now sec square y is equal to tan y plus 1. So it means that in place of this guy here, therefore, dy over dx equals to 1 over. So in place of sec square y, what I will drop is tan y, tan square y plus 1. Right? Now, what is tan square y? But first, what is tan y? From here, tan y is x. So this means that since tan y is equal to x, this implies that dy dx is equal to 1 over. So if tan y is x, then tan square y will be x squared. Okay? Plus this one. So QED. So we have just proven that arctan x is equal to 1 over x squared